The door has been closed and therefore I think it's time to start. I want to wish you a very warm welcome here at the WeAreDevelopers conference in Vienna at this quite early morning. I'm very happy that you join me here for approximately an hour. We will see how long it will take in the end. For approximately 1 hour concerning containers as a service. I promised you that this will be a real workshop with no slides and just demos. And this is what you can expect. I will show you no slides, just demos, everything is live, and we are going to use a lot of preview stuff, so maybe things can go wrong, and it will be very funny for you. It will be less funny for me if something goes wrong, but we will work it out somehow. Let me quickly introduce myself before we go into the topic. My name is Stropek. I come from an Austrian company called Software Architect. It's my own company. We are located in Leonding near Linz. And my professional work mainly deals with cloud. So what I do for the last 10 years, I have been building software as a service and generally cloud-based solutions for our own company. We run our own software as a service solutions, and we help customers, small customers, medium customers, and large customers, building, architecting, and creating software as a service solutions, mainly in the Azure cloud. Azure is the area where I am at home, and therefore this talk will also deal with Azure, of course. I proposed this talk here for the WeAreDevelopers conference because I think it is a very important topic. Containers in general are a very important topic. But if you are like me and you are a developer and you are not that much into maintaining infrastructure. So for me personally, it is a lot of fun building container images, putting my .NET or Node or whatever applications into containers and run them inside of containers. But it is absolutely not funny running my own Kubernetes cluster, setting it up, updating it, patching it, keeping it secure, hardening it. This is not the kind of work that I would like to do. I would like to focus on development, not on administration. I would like to do a lot of dev and a very small portion of ops. So DevOps is okay, but for me it is always DevOps and not the other way around. Okay? So what I really like about the Docker support in Azure is that Azure is very much focusing on offering platform as a service and serverless offerings for people like me. Platform as a service and serverless means that I do not have to care about infrastructure. I do not have to create a VM. I do not have to install Linux, a Core OS, work with Linux Kit, create my minimum Docker host, set up Kubernetes, hardening it and things like that. I just tell Azure, hey, give me a Kubernetes cluster and I get it. And they will care for updating it, patching it, for keeping it secure, scaling it and things like that. So this talk will not be an introduction into Docker or Kubernetes. I will tell you some of the basic concepts so that everything can follow the samples that I'm going to show you. But in this talk, I would like to focus on how Azure supports container as a service. And I will take out and use in my demos 3 different Azure services: Azure Container Registry, Azure Container Instances, and Azure Container Services, which is, at the end of the day, Kubernetes. This is what we are going to take a look in the next, let's say, 45 minutes or so. I will show you, as I told you, a lot of demos. So let me do that one. And I have prepared the samples and I've put it on GitHub. I promised you that I do not use slides, so I have to use ASCII art to show you the bit.ly link. It's bit.ly WeAreDevs-Stropek. It leads you to GitHub, and there you can find the scripts that I'm going to use throughout this demo. If you want to follow along, you can look it up there. And you know, the GitHub stars are the thumbs up, the Facebook likes of the developers. So if you like my GitHub repos, give me a star. I'm always happy about that. So let's start with the first demos. My demo environment where I'm going to do some scripting is Visual Studio Code. And let me give you as the first advice or tip. Visual Studio Code is very good in supporting the so-called Azure CLI. Whenever you create or work with Azure in a scripted way, you can do it in multiple ways. You can use PowerShell. I'm not so much the PowerShell guy. I have a colleague who has really a black belt in PowerShell. I'm more the Bash guy. So I'm more using the Azure CLI. And if you want to program with the Azure CLI, there is a nice little plugin in Visual Studio Code. That's that one. It's the Azure CLI tools. Install the Azure CLI tools and then you have the development environment as you will see it here throughout this demo. The Azure CLI tools, they give you IntelliSense. So for instance, if I say here dash dash, you see nice IntelliSense, it will connect to your Azure subscription, give you a drop down of all your resources, so it will spare you a lot of typing. Visual Studio Code is a nice way of writing bash scripts where you have the Azure CLI embedded. My script is very basic. I kept this script as simple as possible, so this is not fancy bash automation stuff. It's really kept simple because I want to keep the noise content ratio as good as possible, so we want to focus on the commands and the concepts and not so much about writing the fanciest bash script on earth. The first thing that you have to do if you want to automate Azure and work with some container stuff like ACI, ACR, and AKS is you have to connect your Azure CLI session with your Azure account. And this is what you do with AZ login, and then you select the right subscription. I've already done that. I'm here connected to a VM that's running in the cloud. Why don't I execute the scripts from my local PC? Well, it's very simple. I'm going to upload some pretty large Docker images, some 100 megs, and if I do that from here through the conference Wi-Fi or through my phone, it will take way too long. So therefore, I have created a VM in the cloud that has very good internet connection, and I only need a small internet connection from here to my VM in the cloud, and from there on, I work with all my Azure subscriptions. Okay, that's the only reason why I did that. Normally, if I'm sitting in the office, I do all the development locally on my machine, but in here for this conference, I've set up this environment. So I've already connected my Azure CLI session with my account. What I've also done is I've created a resource group. Let's take a look at the resource group. Here it is. I called it WeAreDevelopers, as this is the conference where we are currently at. And in this WeAreDevelopers, we are going to create all the resources for this demo. For those of you who are not that familiar with Azure, Azure resource groups are a way of grouping, combining logically connected resources under a single umbrella. So you can put all your, resources of a certain app or a certain stage, dev test prod, or a certain tenant, or whatever fits to your needs, you can put them all into a single resource group, and then you can maintain all the resources as a whole. You can, for instance, define access policies based on the resource group. You can create the resource group or drop the entire resource group. If, for instance, the tenant canceled the subscription and you want to get rid of all the resources associated to this tenant, just drop the resource group and everything's gone and you do not pay for these resources anymore. So resource groups are a nice way of structuring your things, your infrastructure or platform as a service artifacts in Azure. Okay, I already created this resource group. With that, enough introduction. We are now going into the first demos and the first very important concept. The first very important concept is ACR. Let me show you that in the portal. Here we have ACR. Let me zoom in a little bit, and you can see it better. This is an Azure Container Registry. In short, ACR, Azure Container Registry. What's the whole point of running an Azure Container Registry? You maybe are all familiar with the Docker Hub, aren't you? Is anybody not familiar with the Docker Hub? Okay, some are not familiar with the Docker Hub. To make a very short demo, if I say hub.docker.com, I come to the Docker Hub, and if I, for instance, would like to implement a solution based on Node, then I can look up the Node image. Come on. Look up the Node image here on the Docker Hub. The Wi-Fi is not the fastest one. Let's try it here. I think I have some caches here. Exactly. nearly any server platform that you could imagine that is widespread can be found on the Docker Hub. Doesn't matter if it's Node or Java or .NET or SQL Server or Postgres or Mongo or HTTPD or any other server platform, even Minecraft servers. You can find all of them in the Docker Hub. Docker Hub is for Docker images what GitHub is for source code. But the Docker Hub has one advantage or disadvantage depending on your view. It is public. If you publish something on the Docker Hub, just say Docker push your image and then it's published. If you publish something on the Docker Hub, everybody can pull it down and use it. That's perfectly fine for open source software. Even for some closed source software, that's fine because maybe the customer can pull down your image freely, but he has to buy a license, for instance. That's fine too. But the point is everybody can access your images. Sometimes you don't want that. Imagine you would like to have something like a Docker Hub, but only for your enterprise. Or something like a Docker Hub that only you and your customers and partners can access. This is where ACR comes in. Azure Container Registry, let's go back to the Azure portal here. The Azure Container Registry that you see here is exactly that. It's a Docker Hub. It's the open source container registry from Docker, but executed and maintained in a serverless way. So let me show you how you can create such an ACR. Let me zoom in a little bit again. And oops, I don't want to have this one, and now it should work. It's a single line of script code. You say ACR create, and then you give it a name and some fancy parameters, only a few parameters. Here you see the name, and that's it. It's completely serverless. You do not have to create a VM, you do not have to install any software, you do not have to patch it, you do not have to set up some kind of firewalls and authentication and things like that. The Azure Container Registry is automatically protected by your Azure Active Directory. So you can use your Active Directory accounts to protect access. You can create service principals for accessing it if you want to have programmatic access to your container registry. You can give your container registry to your customers, of course, with credentials, so your customers and partners can pull down images from the container registry. So whenever you have your container images and you would like to share them, either inside of your company in a protected way or outside of your company, but again, not publicly, only to a closed group, then Azure Container Registry is a very nice thing. And for me, as a developer, primarily developer, it is really nice to have this in a serverless way. No need to create a disk or specify a size or whatever. You just push your images and you pay per use. So you pay based on the size, the total size of your images, and they will grow and scale the resource, the container registry as needed. This is done by Azure, and this is what I mean in a serverless way. You do not have to care about servers. Of course, these Azure Container Registries can also be scaled, and especially they can be replicated across the globe. So what you can do is you can create a container registry as we see it here. By the way, here you see the repositories. Currently, I only have a single container image, a single repository down here. And what I meant is this one. If I click on replication, I am here in the standards queue. It's not enabled here. If you enable the premiums queue, it costs a little bit more money. So then you have this world map here, and you just click all the data centers where you want to replicate your images to. So this is very important for those of you who run applications distributed across the globe, because you can keep your images close to your Kubernetes clusters, for instance. So you push your image, for instance, to Europe, and Azure will care for replicating your images to Asia, to Northern America, or wherever you want it. And there you run, for instance, your Docker clusters, and they can pull the images not via a long distance network connection, but from a Docker registry that is located in the same Azure data center as the Docker cluster, for instance, is. So this is another example for the advantage of using the Azure Container Registry in combination with other container services in the Azure platform. Okay? Very good. So how can we use that? We can use that by, for instance, and I have created a very small, or let's create a very small .NET application together. I have prepared a bunch of statements here, and the first one is that one. I will run it and zoom in a little bit, and we'll take a look what that does. This statement is executing a Docker container, doing some volume mapping, so the output will be written to the source directory. And here we use a ready-made image from Microsoft. Microsoft is trying to play nicely in this whole Docker ecosystem. So there are ready-made containers for .NET. And in my case, I promised you to demonstrate how to use the latest and greatest preview of .NET. In that case, it's .NET Core 2.1. It's the version that is currently in preview. And in that case, I'm using this image, you see, to do a .NET new MVC. So we are creating a brand new MVC application by using a container. I have not installed .NET locally. I'm using the ready-made container from Microsoft to create the new application, doing a file new project and writing the results in the source directory. This is what this statement does. If I say, for instance, something like that, you will see that I now have my .NET 2.1 application sitting here. You see the regular startup CS and program CS. I'm sure you are a bit familiar with .NET. You could do the same example with Node.js, Python, or whatever. I'm just bootstrapping a new application. And now I'd like to build this application. And for that, I have created a small Docker file. Let me show you what I mean here. Here it is. Yeah. Okay. I have created a small Docker file for building this application. What does it do? It uses, again, the ready-made container, a container image from Microsoft, and it uses a so-called multi-step build. So what this thing does, it's using the SDK version of the ready-made container for .NET. That means it contains the compiler and linkers and all these things, and NuGet clients and things like that are contained in this image. Then I'm doing a .NET restore, which fetches the NuGet packages from the NuGet server. And then I'm publishing the result into the out directory. And now comes the interesting part. .NET, since .NET Core 2.0, supports multi-step build. So I can add a second from statement, as you can see here. But please notice, and that's brand new for .NET Core 2.1, I'm now not using the SDK image anymore. I'm using a tiny Alpine-based image. Alpine is a very small Linux distribution, and this thing is approximately 61 megabyte. That's the operating system and the entire .NET runtime and the entire ASP.NET runtime packaged up in 61 megabyte. That's huge. You can put a lot of microservices on a server if you keep your images that small. And the only thing that I do is I'm using the result of the build step in the first section and copy it into the second image. So that is essentially a very small Docker file that is a continuous integration and deployment pipeline. Well, deployment, half of the deployment. It's creating the production image based on the Alpine image that is really ready for production use. Okay? This is what this Docker file does. Here you see multiple features that are quite new in the .NET space. First, you see the multi-step build, which is around a few months. I granted that. But the other thing that you see is the Alpine image, and that's brand new, and it will come with .NET 2.1. Up to 2.0, the images were around 150 to 200 megs, and now we get down to a few dozen megs, and that's a huge thing. If you do not need ASP.NET, if you just want to run a console application, you can even go below that. I think the smallest Alpine image for .NET Core 2.1 is currently below 20 megs. Including the operating system, the .NET prerequisites and everything. That's really huge. You can do a lot of interesting stuff with that. So, Let's copy that Docker file, copy the Docker file, oops, not the .NET demo. Let's copy the Docker file one level up into our newly created application. Okay, I created it like that. So let's go into the source directory. And the next thing that I'm going to do is I'm going to build the application with a Docker build step. So let's do that. Oops, it's in the local directory. So what you see here is now the Docker file executing locally. I'm creating an image. Yeah, we are using the preview version, that's correct. I'm creating an image with which I currently called something like that. R Stropek WeAreDevs web app. Okay, it was successfully built. So now if I say Docker images, we should see, let's see, yes, here it is. I already can see it. Oh, I zoomed wrong. Now I see it. Here you see, this is the application that we just created. This is the Docker image where our newly created ASP.NET MVC application is running inside. So if we would like to run it locally, we could run it locally. But the point is, I would now like to take this image and push it into my container registry. So if this would be an open source application, I could do something like that. Docker push, and then use this one. This would now, I zoom in so you can all read it, this would now push my Docker image into the Docker Hub, and everybody of you could create this great MVC application and play with it. Okay, this would be the Docker Hub. But I don't want to do that because Docker Hub is something that probably most of you know. I would like to change the tag of this image. Let me execute that, zoom in, and show you what I'm doing here. I'm taking the original name of the image and I'm changing the prefix here. And this, maybe you recognize it already, is the name of my Azure Container Registry. So now if I say Docker push wearedevs.azure.cr.io/something, it's not going to be pushed into the Docker Hub, but it's going to be pushed into the container registry, which is private for me, for my company, and my partners and customers. Let's try to do that. Just the Docker push. It was very fast. Oh, authentication required. I'm sorry, I have to authenticate. No problem. Try to push again. Very good. You see, it's pushed. Layer already existed, means I have done this Docker push before in preparation for this workshop. Why? Because I want to spare you time waiting, watching this thing, uploading stuff. So it's only a caching mechanism that was active here. Okay. So now we have pushed our new image into our container registry, and if we wanted, we could go to the repositories here. And here we have our WeAreDevs web app, and currently we only have one tag, which is called latest. And of course it supports tagging, it supports multiple folders, so you can use a folder structure to organize your images. You can use webhooks to automatically get informed whenever something is pushed. That is important because maybe you want to automate some processes. If you push a new version of the image, you maybe want to refresh some container instances or web apps, or you want to send an email, a notification email to somebody. So webhooks are a way of letting you be informed by the Azure Container Registry if something interesting is going on in the registry. For instance, a push was successful. Okay? Do you get the idea of Azure Container Registry? Everything's fine so far? Any questions at that point? Nope. Very nice. If you want to run this thing, you could do it in multiple ways. One way would be to create a so-called web app for containers. I will not execute this demo because it's so simple, it's nearly trivial. If you create a web app for containers, WeAreDevelopers demo, let's see if this is already taken. No, it's not taken. If I click on configure container, this is where it gets interesting. So if I want to run a simple web app, the only thing that I have to do is I choose Azure Container Registry. So with that, I create a web farm that is based on Docker that can pull down my .NET Core MVC application, execute, run it inside of my web app cluster, and pull it from my own container registry, not from the Docker Hub. Do I need my own Docker host for that? No. Do I need a Kubernetes cluster for that? No. Do I need any other fancy stuff for that? No. The only thing that I do is I create this small Docker file, put my .NET Core application into an image, create a web app for containers, and I'm done. All the things that you know and love from Azure App Services, like scaling by moving a slider on the screen, adding additional nodes and things like that, they're all here. It's completely Docker-based in the Linux world, and that's a huge thing. And my point is not to go into the details about app services. My point is about the deep integration of Azure Container Registry in all the other platform as a service and serverless offerings concerning containers. Okay? Fine. You can try that yourself at home. I only have 60 minutes, so I would like to focus on different things here. Next topic, breathe in, breathe out, new topic, free your mind. Now we know we have our container registries in the cloud. Now we are doing something completely different. We would like to run our containers. And I've already shown you the app services, but the app services are not my topic. The next thing that I would like to show you is Azure Container Instances, ACI. What is an ACI? An ACI, an Azure Container Instance, is a kind of serverless runtime for containers. It's the simplest way of running any task. It can be a web app, but it doesn't need to be a web app. Any task that can run in a Docker container can be run by ACI. So does this replace Kubernetes or Service Fabric? Or no, definitely not. ACI is very simple. But the beauty of ACI is that you do not need any server. You just say, this is the container, please give me an Azure Container Instance and give me, oops, I have to zoom in here. I need n CPUs, I need so and so many gigabyte memories. You can optionally ask for a public IP address at a certain port. Then you tell it the registry, could be Docker Hub or could be our private registry, and it's done. It runs. And you know how you pay for it? Per processor millisecond gigabyte. So the more memory you use, the more CPU cycles you use, the more money you pay for. It's like electricity. Do you need one of them for 15 seconds? Then you pay only 15 seconds. Do you have a burst in registrations and all the peoples are currently, I don't know, exporting something in Excel and you want to run these Excel exports in a certain Docker container? Well, you can run thousands of them if you want, and you will only pay for the processor milliseconds and megabytes that you really use. That's the beauty of ACI. No reserved servers. No caring about servers, no telling the system that you need a larger server because you're just about adding 100 new containers. You just tell it, this image, this hardware specification, run it. And if it's done after 15 seconds, you do not pay anymore. So ACIs are perfect for running short-lived containers. Imagine what that means for your microservice architecture. Imagine you have this nice little web application and you have this one button that says import data or export data or do some processing, which takes maybe 5 minutes or so. Why not creating a separate container instance for such medium running tasks whenever you need them? It scales like hell. You can create hundreds of them, thousands of them, and you do not have to keep these things in mind when calculating the necessary size of your web servers. It will not cannibalize your web servers. It will run in an isolated environment and it will go away when it's done. You get the idea? Of course, you can run a long-term web server inside of this ACI too. You can. Let me show you that. I have prepared this statement. First, I need to Here I need to get the credentials of my ACR. Let's do that one, and then we run that guy here and add our password. So this is just run a new Azure Container instance, and in that case we are using the newly created .NET Core application that we just created and that we have just pushed into our Docker Container Registry. So it's everything private, nothing in the Docker Hub. Let's go and run this guy. It will be finished in only a few seconds. Okay, if I go here and refresh this thing, we should see if the Wi-Fi works. Yeah, here we are. This is our web application. Here it is. And if we want to access it, no problem. Just go here, run this guy. And if we are lucky and the Wi-Fi works, we should see in a few seconds. By the way, you can take a look at the logs here. If I click on containers, I will see the logs. You see it was pulling down the image. It started the container, and here we are. Here is the MVC app. This is the MVC.NET Core 2.1 app. It's a 2.1 app in an Alpine image. That's important. Only a few dozen megs running inside a container instance, and we only pay for what we really use in terms of gigabyte and processor milliseconds. So I can run my web app here, but it would probably be a quite expensive option. It isn't built for that. It is built for things that you need for a certain time, and then you want to shift it away again. You have a question, please.
Yeah, how long does it take to provision an image? Or are there any guarantees how long it can take?
You have seen how long it takes. It only takes a few seconds. The point that influences the time until your app is available mostly is the size of your image, because it has to pull down the image. Of course, it is of advantage if you have your image in an ACR, in a container registry that is located in the same data center as your container instance. That's the first thing. And the second thing is, how long does it take for your app to start? You all know the things with ASP.NET and Jitter and startup time and things like that. These things are mainly influencing your startup time. Do you have guarantees how long this stuff takes, or do you have guarantees that you have as many ACIs available as you want? No. If you want guarantees, you have to move away from serverless. Serverless doesn't offer you guarantees. If you want guarantees, then you need to reserve service. And this is what you can do, for instance, in Kubernetes, what will be my next demo. I hope this answers your question.
Yes.
Any other questions concerning ACI? Question? In ACI? Not yet. The world is moving quite fast. So it was definitely either on the roadmap. I'm not sure if there is already a kind of preview program for Windows containers on ACI. Please check it by using Bing or your favorite search engine to find out whether this is supported. I personally do not work with Windows containers and ACI, so I'm not up to date with this information. I use only the Linux version. But yeah, that's my answer. Okay. Yeah, one is sitting behind you. I don't know if Gerhard. Okay. There is a Microsoft booth outside, and you can ask them. Okay. In general, a statement. Windows containers are great. I've done a lot of workshops with customers where we evaluated whether they can run their applications in Windows containers. And it works nicely. But if you want to get the most out of container technology, you use Linux. I recently saw this nice little comic, and I always tell that because I think it's funny, where I saw a daddy with his son standing on a field, and they look up in the sky, and the son asks his daddy, "Hey daddy, what is the cloud made of? What are clouds made of?" And the daddy says, "Mainly Linux servers, my son." And that's true to a certain extent. I think you know what I mean. Of course, Windows containers are great, and it's a kind of bridging technology, but they are way larger. You could never create a Windows container with an ASP.NET application with, I don't know, below 100 megs or something like this. So, yeah. Okay, let's go to the next topic. We have 15 minutes left, so we are perfectly in time. Breathe in, breathe out. We are going to enter the third topic in this session. It's about AKS. It's about Azure Container Services, and in particular, Kubernetes. That's preview. That's the pure preview part, so maybe things will go wrong. We will see whether it will work. The Azure Container Services with Kubernetes look like that. If you click on that one, let me zoom in a little bit so you can see it better. Here I have created a Kubernetes cluster before this talk. Why did I prepare that one? Well, it takes approximately 10 minutes to provision a new Kubernetes cluster. And I didn't want you to watch me 10 minutes watching the screen, seeing some ASCII art going on, telling us that it is currently creating a cluster when we only have 15 minutes for that. So I created that Kubernetes cluster up front. And you see, you can configure this cluster, you can scale it, you can upgrade it. It's very simple. It's a platform as a service offering, and you do not have to care about the VMs and the sizing and the patching and things like that. It just works. Okay? Well, you can take a look behind the scenes, and that's an important one. If I zoom in here a little bit, you will see that we have a resource group which is called WeAreDevelopers. But a little bit up here, you see that we have another resource group which is called MC WeAreDevelopers, We Are Devs West Europe. And this is the Azure resource group where the underlying resources are at home. So we can take a look at this resource group, and here we will see a lot of fancy stuff. We will, for instance, see a virtual network, we will see a load balancer, multiple public IP addresses, we will see a storage account, the virtual machines, and all these things. So behind the scenes, Microsoft is creating the necessary IaaS parts, infrastructure as a service parts, for you if you configure a Kubernetes cluster. A managed Kubernetes cluster. But you keep your hands off that resource group. Don't touch it. It belongs to Microsoft, it's managed by Microsoft, and you can only change it if you really know what you're doing, or if Microsoft support tells you that you should do some specific things. This is managed. This is the managed part. If you do not have AKS, and if you want to just run it based on virtual machines, you would have to create all these things by hand and yourself, and we do not want to do that. We just want to have Kubernetes. And if you want to publish a Kubernetes cluster, a managed Kubernetes cluster, you have to create some service principles. That's some security stuff I'm not that interested in, but this is the only line that you really need. AKS create, give it a name, here you see it, specify a service principle that it should use to access your Azure Container Registry, and here you see my super secret password for this demo, and that's it. That's the only line you need. It's a one-liner, and you have a production-grade Kubernetes cluster that's fully managed. Do you want to upgrade it to a new Kubernetes version? It's done by Microsoft for you. Just select the drop-down box and you are done. The Linux machines, everything is managed for you. They create the virtual networks, the IP addresses, and all the other stuff. Okay? So, as I told you, this is the Kubernetes cluster. And now, if I want to work with this Kubernetes cluster, okay, I could say kubectl get all. For those of you who are a little bit familiar with Kubernetes, you will know this CLI. That's the kubectl CLI that you are used to, that you use maybe now for your on-premise Kubernetes servers. That's the same API which the Azure AKS Kubernetes is answering to as you are currently using in your infrastructure. But the point is, I don't have to maintain it. It's done by Microsoft. How much does it cost? Well, it's free. You only pay for the underlying infrastructure. So you pay for the virtual machines, the network, the network traffic, and so on. But the management, the whole automation that Microsoft has built for automating this Kubernetes stuff is free. And that's a very good news, isn't it? You just pay for the virtual machines. Everything else is done automatically. So let's try to run our brand new .NET Core 2.1 application based on the Alpine image inside of our Kubernetes cluster? It's very simple. I've prepared, let me show you that first. I've prepared a manifest, let me zoom in a little bit, that is used to deploy, it creates a deployment to deploy our web application. Let me quickly walk you through, because before this workshop I asked who is familiar with Kubernetes and I didn't have all the hands up. So let me quickly walk you through this code. This is a so-called manifest WAML file. So it's essentially a JSON file without the curly braces. So it's just JSON, it's just a configuration file. And what this configuration file, what this Kubernetes manifest does, it's creating a deployment. A deployment is a combination of a so-called pod. A pod is what in Docker you typically call a container. So a pod is a little bit more than a container, but for now, to keep it simple, it's just a container together with a so-called, you see that here, replication controller. Where is the replication controller? Here. Here is the replication controller, so you can tell Kubernetes how many instances you want of that thing. And additionally, it's managing so-called rolling updates. So if you update your .NET Core application, it does not tear down your entire application and you are offline, and then it's updating it, and then it's booting everything up again. So you do not have a downtime. But if you run multiple replicas, for instance 5, it takes down one, updates it, brings it up again, takes down the next one, updates it, and brings it up again. I think you get the idea. That's the concept of rolling updates. And a deployment, as you can see it here, is, as I said, a pod plus replication plus rolling updates. Everything is configured inside of this configuration file. The next thing where I would like to draw your attention to is that guy here. Do you recall what we have here? This is our Azure Container Registry. So my Kubernetes cluster is pulling my .NET Core image, not from the Docker Hub, but from my private serverless container registry, which of course happens to sit in the same Azure data center. So they have a very strong network connection because they are sitting side by side, in my case, near Amsterdam. They are sitting in the Amsterdam data center, and they have quite a good bandwidth between them. The second thing that is done inside of this manifest file, you see it here, we create a service, you can see the service, of type load balancer. A load balancer means that the container is connected to the public internet. The port is exposed. So in that case, we are looking up the web app that is defined up there, and we connect it to the outside world via the port 80. This is what we do here. And you know what Azure does behind the scenes? It recognizes that it has a new service, a new load balancer service. It will assign all the necessary things like a public IP address. It will provision the public IP address. It will do the necessary network configuration. Everything is done automatically. You do not have to write a single line of script for that. It's just immediately available on the web. And if you would have a more complex application that needs, for instance, in the backend, some additional microservices, or a database, or a Redis cache, or whatever, you could put all these things inside of this WAML file, and it will automatically deploy all the necessary containers. You can take some of the images from your private container registry, but maybe you take some of the images from the Docker Hub, like the Redis cache. You do not have to import the Redis cache in your ACR. You can also mix and match your private registries and the public registries as you want. Okay? So let's check this. Let's check this and try it. In order to not do some typos here, I do that one. Whoops. Apply. That's not a good idea. It should say apply. And I'm already in the demo directory. Now we are talking. So what what I created here is the brand new WeAreDevs web app. You see it here, and the service unchanged means I have already created the service up front. Why? Creating a load balancer service means that it must provision a new public IP address. And provisioning a new public IP address for the first time means that we have to wait between 2 and 5 minutes. And I didn't want to wait 2 and 5 minutes. So therefore, I just created the IP address up front, and I only deployed the .NET Core application and linked these things together. So the IP address belonged already to me. That's the only trick that I did here. So if we say kubectl get all, for instance, then we see here we have our deployment that resulted in in the load balancer. Here you see the public IP address. We will need that in a second. And yeah, that's it. That is what we created. So let's take this public IP address. And if the demo gods are smiling and I paste this IP address here, wow, this is it. This is our Alpine image with .NET Core 2.1 preview from our private container registry deployed in a managed Kubernetes cluster running inside Azure. This is what I wanted to show you. Okay, let's quickly take a look inside of our Kubernetes cluster. The nice thing is that Azure supports running the Kubernetes browser portal locally. I'm just spinning it up. Here it is. This is the management portal. Now we are looking into our Kubernetes cluster. And if we scroll down here, you see you can now graphically maintain this stuff. If I click on deployment, you see this is our deployment. It is up for 2 minutes. So this is exactly what we created now. I can go into the details here. You will see all the nice things. You can watch the configuration, and you can also take a look at the services, for instance. We should see the services with the public IP address, what I previously created, and all of the other things. I do not have to set up this portal or things like that. It's fully managed for me. I can do that. What else do I get from using a managed cluster? Unfortunately, I do not have time to demo that. You can take a look at my examples. I can just tell you what you can, for instance, do is, I can show you that here. You can create so-called, where is it? Persistent volumes. Because sometimes you would like to run a container in Kubernetes that is stateful. Think of SQL Server, think of Postgres, think of MongoDB, think of maybe your MVC application that stores some images locally. Of course, you do not want to store your data inside of your container. You want to use volumes for that. And these volumes have to be secure and have to be highly available because that's your valuable data. The problem that you typically have if you run your own Kubernetes cluster is, where do you store this valuable data? You need to configure your own volumes, and you have to care for backing it up and creating a file, network attached file system that is high secured and things like that. If you run the Azure Container Services in Azure as a service, you get integration with Azure Storage out of the box. So the only thing that you need to do, you see that in this demo file. Let me show you that. I have it here. It's a little bit easier to see. Here it is. That's the only thing you need. What you see here is that we are using a special driver, Azure File Driver, and with that we can use Azure Storage, Azure Files, and Azure Disks inside of Azure Blob Storage as our persisted volumes for Kubernetes. So if your container, for instance, stores some files like a SQL Server, a Postgres database, to a certain folder, in the background the files are written to Azure Storage. And there you have a storage cluster, which is high secure, highly available if you want to replicate it to a second data center on a different earthquake zones, and so on and so on. And you do not have to configure that stuff. This is why I personally really like this approach of platform as a service and serverless. Time's already up. I hope it was a fast hour and an interesting hour that we spent together here. Let's quickly recap what we have done. I promised you to show you .NET Core 2.1 preview, the latest preview of .NET in Azure Container as a Service. What we have started with creating a brand new .NET Core application, and we published this .NET Core application into our private container registry. Then we have taken this container registry and we have used the second service, Azure Container Instances. Azure Container Instances was the serverless stuff where you pay what you really use. You pay like electricity, not like a hotel. I spent the night in a hotel here. If I don't sleep in the room, I still have to pay it. That's classical infrastructure as a service. You reserve a server. If you don't use it, you have to pay it. Not with ACI. With ACI, it's like electricity. You pay for the CPU cycles and the memory that you really use. This is nice for short-lived workloads. If you want something more long-lived, like web applications, microservices, stateful containers, then you probably use the third option that I knew, Azure Container Services, AKS. It's managed Kubernetes, which is deeply integrated into Azure, so you can use things like Azure Storage for volumes. You can use the container registry for pulling down your containers based on service principals and passwords and access policies that you define. I hope it was an interesting hour. I would like to thank you for coming so early in the morning to this talk, to this workshop. And yeah, with that, I would like to open it up for a few questions, if there are some. Do we have it? Thank you.
So I have a question. Super interesting talk. Thanks.
Thank you.
Is there any way to try this for free?
To try this for free? Well, it happens that I have something in my hand and I take a look at it and it says $100 of Azure services for 1 month for free. So if you would like to play around with the things that I've shown you here, come to me. I will leave it here in the front. You can pick one of these. You get 1 month, $100, and you will only need a few dollars for creating these things, because when you're done, you can just delete the resource group and you will not pay for it anymore. So thank you, Gerhard, for that. I will leave it here. Any questions? Yeah, question.
What can we find in the link you gave us?
This script. So what you will find in the link is you will find this script here. And you will find the WAML files for creating the storage, for creating the .NET application, for a demo that I typically do in longer workshops with Nginx, where I store an Angular application, for instance, in Azure File Storage and link it up with an Nginx web server. This is what you find behind this link. But behind this link, this is a subdirectory inside a larger repository. It is my whole Docker workshop repository, and if you move up in the directory tree, you will find many, many slides, my entire workshop slides, all my workshop samples. Everything I do in workshops and talks and things like that is MIT licensed or Common Creative. I also record this session. I will put it on my YouTube channel. So if you would like to be updated in what I do and what I publish, just follow me on Facebook, Twitter, watch my repositories on GitHub, link you up on LinkedIn, Zing, or whatever you want to do, and you will always be kept updated whenever I do sessions like that, and you can watch, for instance, the videos. So take my content, share it, redeliver it, do whatever you want, and if you find a bug, send me a pull request. So yeah, we have one final question.
An actual question. So if around PCI, right? If you have a decision to design a software and you have like a short running something which is designed for ACI, right? How do you decide to go for ACI or to go for Azure Function? So what are your triggers?
Okay, I will repeat the question because I'm recording it. If you have a short-lived workload and you have to decide whether you want to run it in ACI or you want to use an Azure function, how do you decide? To be honest, it's even more complicated because you can use the Azure function runtime inside a container and run the Azure function runtime in ACI. My advice would be use Azure functions whenever appropriate. Azure Functions are even more serverless than ACI. Azure Functions give you a lot of additional features and tricks when it comes to serverless programming. Use ACI only if you have specific reasons why you can't or why you don't want to use Azure Functions. Because maybe this is too much lock-in effect for you, you want to be very, very platform independent, then maybe you do not want to go for Azure Functions. That could be a reason. It wouldn't be my reason, but it could be a reason. So this would be my advice. Prefer Azure Functions and use ACI only if this does not fulfill your needs. Okay, thank you very much and enjoy the rest of the WeAreDevelopers conference. Thank you.